Hello, we are TeamAMP. I'm Sean, this is Cameron, this is Jim, this is Zach, and this is Noah. Our advisor is Professor Swing, and our client is Yvonne Che from the math department. We are currently using the waterfall process model. A MOOF is a best fit program that finds the optimal solution with a given data set. The optimal solution is created by taking the data set and fitting it to a line based on a set of unknown variables, also known as Greeks. Before MOOF 1.0, this whole process was done manually. They would have to enter each function by itself. And then after they've entered each function, they would have to run each piece by itself. The creation of MOOF 1.0 nearly a decade ago allowed the automation of this process, which greatly speeds up the time greatly decrease the time in which it can be run. However, with Excel 2010, it stated that it would be backwards compatible with all previous Excel versions. However, with MOOF 1.0, this wasn't the case, as it broke. This brought out the commission of a MOOF 2.0. With the MOOF 2.0, we're trying to improve upon a MOOF 1.0 by adding additional features such as bias tail correction and allowing the user to select individual PDFs, as opposed to the way MOOF 1.0 did it, where it would run all of them, even if you didn't want all of them. This should speed up a little bit more, but more importantly, we're trying to decouple a MOOF entirely, or for the most part, from Excel, but we aren't able to take it completely out. We'll explain that a little later. I now pass the floor over to Cameron.
Alright, so this is a high-level structure of our system, and it is comprised of 6 main components, and the main one is the controller. The controller component acts as a central hub for the exchange of data throughout the program and gives the system modular capabilities. This modular implementation allows each component to be developed individually by removing any possible dependencies on other components. And for our project requirements and explanation of this high-level structure, it felt appropriate to use a use case to move through it. So we have Mary the actuary. Mary is an employee at Fubar Insurance Company. She is given a set of data that contains information about each policyholder's car and a weighted number of claims. Mary is told to analyze males aged 16 to 25 and told to find the probability that a policy holder who owns a fast car will make a claim over a certain period of time. Alright, so Mary begins by starting up MOOF 2.0 and begins interacting with the GUI. The GUI system contains storage for the user settings and preferences, handles the import, export, and display of data and results. Once Mary's data set's been imported, the controller calls the graphics system. The graphics system is explicitly used for drawing graphs for a GUI, and it will, after she first imports the data, the graphics system draws a histogram, and then the controller also calls the statistics system to compute some initial statistical calculations. Next, the GUI system waits for Mary to set the calculation settings and click Calculate. Once Calculate is clicked, the GUI passes data through the controller to the PDF system. The PDF system dynamically creates PDF objects for the given data based on Mary's preferences and returns them to the controller. The controller then passes the PDF objects to the solver system, which optimizes for each PDF its Greeks. And after the solver system returns these values to the controller, the results are passed again through the controller to the graphics system and the GUI. The graphics system prints the last graph, which has all the data on it, including the distribution, and is is shown on the GUI system so Mary can analyze and export it if she wants. Next gym will cover the solving more detail.
In order to optimize PDFs, we needed to use a piece of software, usually called a solver. It's very complex, and we would not have been able to implement it ourselves. The existing program used the solver that comes with Excel. The existing program is developed in Visual Basic for applications, which is a very procedural language. We wanted to do a more object-oriented design, and we wanted to use Visual Studio and C#. The problem is that Visual C# can access Excel spreadsheets through the Excel object model, but it can't directly access the VBA code that was developed within Excel. When we researched it before, we also couldn't find a way to control the solver. So we looked at other solvers. There's some open source ones. A lot of them were not, linear, and we need non-linear optimization. They were based in Linux, which wouldn't really be good because users are going to be using Windows 7, and there are also some installation issues. We found the Microsoft Solver Foundation, which is a framework. It provides an abstract layer that you can plug in various solvers into. It provides nonlinear optimizations, and it is compatible with C# and Visual Studio. And so we decided to attempt to integrate this framework into our own C# program. We began implementing the PDF functions. There are 44 formulas in all, and after a while we began to run into some problems. The biggest one is that the abstract layer of the Solver Foundation requires, it needs to understand the model you're trying to optimize, so everything must be built within the model using its own set of tools. For example, it has its own power function, its own square root function. It doesn't have a gamma function, which is required in the majority of the PDFs we're trying to optimize. We tried to build a model of the gamma function, but this also was not, we couldn't do this because it requires an integral, and the approximation for this function requires while loops and other conditional statements, which the model did not provide. It basically wasn't designed for that sort of thing. Other issues is that we implemented the functions that we could implement. Almost half of them were coming up with the wrong answers, even when we gave it the correct starting point, so it diverged away. In order to continue with the Microsoft Solver Foundation, we would have to bypass the abstract layer that it provided and go directly to the solvers, accessing their direct API. And I looked into this. There were only 2 solvers that looked like they might work with our nonlinear functions, and the most promising one had very little documentation, so we really couldn't move forward with that. The explanation is basically, I believe the Microsoft Solver Foundation has a lot of nice functionality, but most of it is with linear optimizations. The nonlinear optimizations are relatively new, so it's not really as user-friendly as the Excel solver, which has been around for a lot longer. And it may still be possible to use the Microsoft Solver Foundation, but we simply ran out of time. And I will let Zach continue.
Once we determined we had inadequate resources to fully understand and implement the Microsoft Solver Foundation, we made the decision to revert to the Excel solver. This was part of our disaster recovery plan in case something like this did happen. Even with this setback, we still decided to try and avoid Excel as much as possible due to some of, I'll get into it in a second. And it was also one of the big sell points for this software is that it was a standalone application that didn't require Excel at all. And at this point, we'd already developed a significant amount of functional code in C#, and also developing an application, the can successfully interact with Solver requires us to write VBA code that Jim mentioned earlier. Now, this is a language the majority of the team is unfamiliar with, so converting from C# to VBA would not only mean we would lose most to all of our work, but we would also be learning a language on the fly. This also goes against kind of our coding that we've learned is object-oriented, is the style that we wanted to approach this with. Obviously, with the modular approach, we have to do object-oriented programming. So we put our heads together and came up with a plan of action to access Solver without programming with Visual Basic for applications. In order to accomplish this, we had to gain access to the Solver plugin without accessing Excel. Turns out, this is impossible without breaking copyright laws. The solution we came up with was to minimize the use of Excel, more of a compromise. We ended up accessing the Solver plugin by porting into Excel with C# and writing VBA macros we were able to extract and generate and then modify for our use. As far as we are aware, this has never been done and definitely is not documented anywhere we found. So it took a great team ingenuity to solve this problem. Thus, we have not made an entirely standalone application, but have made a step in the right direction by extracting everything from Excel with the exception of the essential Solver add-in. I will now pass the floor to Sean so that he may demonstrate the program to you. I'll get to it.
This is our UI. It hasn't changed too much from the last iteration. The biggest difference is that our last iteration we were showing you what it would look like with real data, but it was all fake data and fake graphs. This is work in progress. You can import data from a file and from a CSV, and it populates the data. It takes a second to finish populating it. When it's done populating, it comes up with a histogram preview, which is this right here. And again, this is just, it's still work in progress. So we're going to select a few PDFs. And the raw data is shown here, just in case you'd like to view it. But by default, it's hidden. After you've imported data, and you've selected which PDFs you'd like to run, you can then run the calculation. Currently, it doesn't display anything, but it does actually do the calculations. We're still, again, work in progress.
As far as the rest of it goes, this is our development one. This is the actual functional one. It's not the pretty one that we made before. So everything you see is something that's actually being generated from real data, not just the fake images that we made to kind of give you an idea of what the final product will look like.
And with that, I pass it off to Noble.
In addition to needing to meet all the functional requirements of the original Move 1.0 software, there were also additional requests and requirements supplied by the client that we felt that we should also meet. One of these, I suppose, was not directly involved with that, but something that we decided as a team, was that the histograms, graphs, and such supplied by .NET, supplied by Excel, were simply not going to be sufficient for what we wanted to do. They were not flexible enough, they were not malleable enough, they may not have looked very good. We needed a good way to present the data. The histograms are a very important part of this project. The user needs a way to quickly and easily digest the data in a visual fashion. So we decided to create our own histogram class, which is what you saw, creating our own histogram. And this will scale, it will show lines, bars, or both, and should scale up from a very small thumbnail all the way up to a full screen image while still retaining a good, clean look and conveying that necessary information to the user. We're also implementing, as Sean mentioned, bias tail correction. By their nature, the tails are a less accurate portion, and bias correction does help to correct a degree of that, and it's a necessary component, so we are building that into the software as well. Another thing we're doing is selectable PDFs. The original Move 1.0 software would run basically everything. A large number of PDFs, you just say, here's the data, run it, and then you had to check through that yourself. It was a portion of wasted time. It was unnecessary data that the user may not have even wanted. So we have integrated the ability to choose which PDF you want to run, a single, multiple, all of them, as well as additional options for these PDFs. And we feel that's an important thing for the user as well. Another thing we're doing is generating reports. Once the software is done, the calculations are run, you can view the results and take a look at what you've got. But it will also allow you to export this into a report. And this is something that we feel is vital because it allows the user to take all that digested data, place it into a report in another format that they can take with them, show other people without the need for the Move software. You can take the result and leave the rest. This will also use moments to generate unknown Greeks, and without getting into too much detail, in a nutshell, this could be considered a sort of alternate method of processing the data that can be checked against the solver process data to ensure accuracy. And that's another feature that we have added to that. And now we will go back over to Zach for quality assurance.
All right, so basically we're going to cover what we've done and what we need to do. What we've done so far is with the solver system, we've done extensive white box testing with the solver system. This is mainly due to the unstable relationship between solver in Excel and C#, and our need to see where the errors occur. The reason for this is the Excel solver exists in the COM environment, which I'm not very familiar with, while Visual C# exists in the .NET environment. And any COM errors that occur are very non-descriptive. They don't really tell you what's going on. It just says it's a COM error. So this obviously requires us to open things up. And we had to be able to see the code at a very granular level. This is on both ends. This is the C# and the VBA code that was produced. This has been quite an experience doing this because we're operating in two different debugging environments at the same time. And one was the debugging environment that is built into Excel with the VBA, and the other one is the Visual Studio debugging environment, which I'm sure we're all familiar with. We've also done some black box testing with it because we've made it a little bit more stable. We're able to run things without it crashing, so that was a big hurdle, especially with the limited amount of time, considering we had that major setback. For all of our other systems that Cameron discussed, we have done function level and system level testing with both white box and manual black box tests. Our black box testing has been possible because of both the original Move's outputs and Dr. Che's invaluable contributions. We've also kept Dr. Che updated with our progress during the client meetings and used her feedback to make changes to the project. For future quality assurance, we want to do automated unit testing. We want to be able to do this so that we can test at a granular level with a wide range of different data inputs without being around, without having to administer these data inputs. We want to do system integration testing. We started this actually because we obviously showed you a prototype, but it's important that each system works well with each other. We haven't fully tested that yet. So with our modular approach, we've been able to parallelize the development process. That is, no module is dependent on another function, as Cameron mentioned. We want to do automated full system testing. So we want to just sit back, tell the program to go through this collection of data sets and record the results, see where errors occurred, where mismatches occurred, and match these results to what a Move 1.0 produced. We also need to do client and user acceptance testing. This is the most important part of the entire testing process. The reason why is because there's going to be a wide range of users within the actuarial field, and they need to have a good feel for this, and they need to enjoy using it. They need to have a good user experience. Moving on to our risk analysis. What we see highlighted is our major risk. We discussed this earlier. I'd just like to touch base with this again to let you know that we did have a fallback plan for this. This is something we didn't expect, we hoped it wouldn't happen, but we planned for it just in case. And that's actually the end of it because we already discussed that. And I will give the floor to Noel to wrap things up.
In conclusion, we feel that we have hit a number of obstacles. As we've seen, we had some trouble with the solver frameworks and had to resort to a fallback plan. But we feel that we have done a good job at overcoming these obstacles and getting around them and finding out what needs to happen in order to make this software work. And we feel that the work is progressing well, and we feel that by the time things are ready, we will have a solid, polished piece of software for our client. In addition, I believe that we are all learning a great deal. This is a field, of course, where you can't sit still. You always have to be learning. And I feel that this is a vital part of the learning process, and I think that the client will be better off when we're done, and that we as a team will also have learned a great deal of valuable things. So, thank you. Any questions?
Yes.
So you want to be able to export to reports?
Yes.
What is the format of those reports? Would you elaborate on that a little bit?
We want to be able to support various types. PDF is the ideal. I'm not sure if that's going to happen. Obviously, it's the cleanest, most professional. But we're looking into probably Excel spreadsheets, because that's what it seems like most people are most familiar with. CSVs are kind of a fallback because everybody does CSVs, but since we've already are capable of accessing Excel through our program, we might as well produce a spreadsheet. Does that answer your question?
Yeah, you have these graphs and such. Are you planning on being able to try to export those as well too?
Yes, and for probably in a PNG format, because that usually keeps most of the integrity. Yes, Dr.
So, you have this major setback, but I'm unclear, did that change any of the requirements? So, we had a limited time, was there anything that got dropped? Because you now taking the time to do it.
Yes, there was something that we dropped. It was something that we had planned to originally implement, the KS test algorithm. Part of it is that we just didn't need it. It was something extra we were going to do. So with all the things that we have to do now, since this we were set back 4 weeks, we had to put some things on the back burner to catch back up to where we should be.
So it was just the one sort of optional feature that you had?
Yes.
Okay.
Thus far.
So far?
Yeah.
Okay.
We're doing an extensive meeting tomorrow as far as what we have to get done and how much time it's going to take with where we are now.
Okay.
So.
Is that a question? No? Okay. Yes, thank you.
Thank you.